Hello there, ladies and gentlemen. Well, welcome to our help video on our lab, Density of Pennies 1-9. In this video, what we're going to do is go through what happened in the lab. We're going to take a look at why we did the lab, what happened in the lab, and what we can interpret from what we observed and the measurements we made during the lab. First of all, the purpose of this lab was to determine the density of pennies. And in this lab, we determined the density of pre-1982 pennies, post-1983 pennies, as well as some of those gold pennies that we saw. Part of the reason we were using density is a physical property. And physical properties can be used to determine what a substance is. And it can lead us to be able to determine the composition of that substance. Remember, physical properties are properties that can be looked at without changing what substance is there. Physical properties are different than chemical properties. We did not want to use chemical properties to determine if the pennies were actually gold, because if you use chemical properties to determine if the penny is actual gold, we might do a chemical reaction which turns that gold into another compound, and that could greatly ruin the value of that gold. So when you do a chemical reaction to look at chemical properties, you can turn that substance into a different compound that has different properties entirely. So physical properties were used because, first of all, density is something that is easy to measure in something. You just need to know its mass and its volume. And secondly, when you use physical properties, you're not going to change the substance into a different compound entirely. What you start with when you look at physical properties is what you end with. And that is what is being discussed on this first page here. Again, density is the mass divided by the volume. So in this lab, we had to measure the mass. We used the balance. We had to measure the volume, and they did that by the displacement method, where they dropped the pennies in a graduated cylinder that had water in it already. And by watching how far the water level went up, we can determine what the volume was of those pennies, because an object will displace its own volume when placed in water. So if the pennies were 2 milliliters and we put 2 or 20 milliliters of water in the graduated cylinder, when we drop the pennies in, if the pennies were 2 milliliters, the water would go up to the 22 milliliter mark. 22 milliliters minus the original 20 milliliters would tell us that the pennies had a volume of 2. So this is how we did it. Again, the displacement method is discussed right here. Displacement method was how we determined the volume. One thing that this lab intended to prove is, does density matter, or is it density impacted by the amount of the substance you're determining the density of? In other words, does density change if you're measuring more of the stuff? Is density less if you are measuring less of the stuff? And the way they wanted to tell us, or to prove that in this lab, is when they did this lab, as you watched it, the scientist put a group of pennies on, measured its mass and volume. Then he added more of the same type of penny, added another group of pennies, and measured their mass and volume. Then he did a third group, a fourth group, and fifth group. He kept adding pennies to the balance. And the purpose there was to see, does the density change as you change the amount of pennies that you're measuring? And that's what this lab was, another thing this lab was trying to prove. And then, of course, another thing the lab was trying to prove is the density of pre-1982 pennies different than the density of post-1983 pennies? And the way they were going to do that is measure the density of pre-1982 pennies, measure the density of post-1982 pennies, or post-1983 pennies. If the density were the same, then they are the same type of penny, same composition. If the densities change, then the pennies composition must have changed. In other words, they must have had a different mint or used different substances to make the alloy. An alloy is a mixture of metals in a substance. In order to prove if the pennies were gold or not, in the last step of the lab, if you recall, they were determining if the pennies were gold. In order to do that, you need to know what the densities are. Turns out the density of copper is about 8.9, the density of zinc 7.1, the density of gold 19.3, and brass, which is an alloy of copper and zinc, is about 8.4, depending on the percentages of copper and zinc in that alloy mixture. There's our purpose, there's our procedure, and here they go with the lab. First, they started with a collection of pennies called Group 1. He put several pennies on the balance. He called those Group 1. These are pre-1982 pennies, and the mass was 15.402. Then he dropped those pennies in a graduated cylinder. The cylinder started with 22.5 milliliters of water. After he dropped, or started with 22.5, it started with 20.5 milliliters of water. After he dropped the pennies in, it started with 20.5. After he dropped the pennies in, it went to 22.5. So that group of pennies, 22.5 is what it went to, 20.5 is what it started out. That group of pennies had a volume of 2. Then he added some more pennies to the balance and added a second group to the Group 1 pennies. The reason it says Group 1 and 2 is Group 1 was still on the balance. He added Group 2 to it. The mass went up to 38,804. The volume in the cylinder went up to 25.5. It started at 20.5, so the volume went up. Now it went up a total of 5. He continued to add groups of pennies. He added more pennies, which he called Group 3. To Group 1 and Group 2. So 1 and 2 were still on the balance. He added Group 3 to it. The mass went up to 46,101. The volume went up to 27. 27 minus 20.5 is 6.5. By the way, this volume part was very difficult to see. So these numbers you could see on the balance pretty easy. The volume readings were very difficult to read. I did my best to guess what they were. These are numbers that I tried to read for you, the 22.5, 25.5, 27, 28.5, 30.0. Those were numbers I tried to read, but I had great difficulty reading those. Reading the volume in a graduated cylinder, you look at the lowest point of the water in the graduated cylinder. That's called the meniscus. Water takes that little smiley shape in the meniscus. The graduated cylinders, to read it at the bottom. When you try to read the meniscus in that graduated cylinder was going up by 1 milliliter at a time. Very often the line was between there. So sometimes it looked like it was around 22.5. But it could have been 22, or it could have been 23. It could have been 22.25. It could have been 22.75. I was just guessing that it was 22.5, about in the middle. We'll see that this decimal spot here, if you're off a little bit on that decimal spot, it introduces error into the lab. But that error is acceptable. So we just continue on with those different groups. Here's the masses of the groups, and here is the volume change, the volume of the pennies. So for instance, the final pairing had 5 groups on there. He added a 5th group. The total mass was 76.857. I thought the volume got pretty close to 30. It started at 20.5. Oh, I'm sorry, 30.5. It got to 30.5. It started at 20.5. That was a change of about 10. Again, I'm guessing. Same thing for the post-1983 pennies. Here's the masses he measured. The volume in the graduated cylinder this time was right about 21 when he started. Each time he dropped the pennies in, the volume continued to go up. So this is what the final volume was. Group 1 pennies, the volume was about 23. It started at 21. The difference was about 2. Again, I had trouble reading these. You might have looked at it and thought, where am I getting my numbers? I just did my best. So that's the data for the pennies that were minted or produced after 1983. Here's the values for everything that was pre-1982. And then the part I did, you had to click on this little video. I started with several gold pennies, put them on the balance. I just did one group. I didn't keep adding them on because we'll find all we needed to do that was for these two. But the pennies that I put on the balance was 30.72. In the graduated cylinder, I started with 30 milliliters. When I dropped those pennies in, the volume went up to about 34. I thought the volume then of the pennies, it started at 30. The water was pushed up to 34, so the volume of those pennies was 4. So that is the data that we collected. Now we were asked to do some calculations. They wanted us to calculate the density of the 1982 pennies, the ones that were pre-1982. So we had to go back to the data. We go back up. The mass of group 1 was 15.402. The volume of group 1 was 2. So we plugged those numbers in. 15.402 divided by 2 is 7.7. Double check my math. Now you might say, Mr. Rinkelmeyer, why did you round to 7.7? Why didn't I keep more numbers? 7.68 something, or whatever it would have been. The answer is you have to look at the numbers you used in the calculation. The balance gave us 5 numbers. The graduated cylinder, I was guessing. I knew it was about 2, but I was guessing how close to 2 it was. I said it was pretty close to 2, 2.0. So right here, I only had 2 numbers. When you decide how to round your answer, you don't round it based on how many numbers are past the decimal place. You round it based on how many numbers you used in the calculations, and you pick the one that had the fewest. So this had 2 numbers, so my answer is only allowed to have 2 numbers. That's called observing significant digits. The second one, the second mass, when I added group 2, or when he added group 2 pennies to it, the mass went up to 38.804. 38.804. Then, what did the volume do? The volume looks like it changed about 5. The volume looks like it changed about 5. There it was. The volume changed about 5. We plug those numbers in. 38.804 divided by 5 is about 7.7. Again, this has 2 numbers in it, so my answer should reflect 2 numbers. So these have been rounded. You know, you round to how many numbers, not to what place there is on a decimal when you're dividing and you're trying to observe significant digits or significant figures. 46,101, that number was right here. 46,101, that was our mass of the group 1, 2, and 3 pennies. The volume change was 6.5. So we go ahead and put 46,101 divided by 6.5. This one surprisingly came out to 7.1. 7.7, 7.7. This one came out to 7.1. Should that concern us? Well, maybe, maybe not. And we will see later that really anything between 7 and 8 here would be considered relatively close. We'll look later that I know that I was kind of estimating that 0.5. Maybe I estimated that incorrectly. We continue on. I'm not going to refer to every time we look at the calculations. But in the seconds, we would get 7.7 here, and we get 7.7 here as well. And these numbers came from the data table. These numbers right here came from the post-1983 pennies. We'll take a look at how I calculated those numbers in our next help video on this lab. Thank you for watching.